Many a times in the electronics world, we find the need to reduce one DC voltage to a lower one. We feel the pressing need to find something that can step DC voltages down and do it efficiently. Luckily, such a device already exists. It's called a buck converter. It's a type of DC-DC converter. It accomplishes the task using a few transistor switches and an inductor. A typical buck converter circuit is as shown. Welcome to the Curious Pug. In this video, we will be doing a tutorial on how to design a buck converter. To design a buck converter, we require 5 parameters. Number 1, the input voltage or the source voltage. Number 2, the output voltage. Number 3, the load resistance in ohms. Number 4, switching frequency in hertz. And finally, number 5, the voltage ripple, which is the periodic variation in our output voltage. I am going to design a buck converter for an input voltage of 50 volts, an output voltage of 20 volts. My load resistance is going to be 10 ohms. I am selecting a switching frequency of 50 kHz, and I am going to assume my output variation do not exceed 4%. Keep in mind, you can insert any value of your choice. After deciding these parameters, all that's left is a few calculations. Step 1. Duty ratio, D. For buck converter, duty ratio is the ratio of output voltage to the input voltage. Substituting the values we decided in this equation, we get a duty ratio of 0.4, or 40%. For people who are wondering how I got these equations, I will leave a link in the description as to how these equations were derived. Step 2. Inductance, L. For buck converter, the minimum value of inductance is given by the formula. L minimum is equal to 1 minus D multiplied by the load resistance, all divided by twice the frequency in hertz. Substituting the values in this equation, we get the minimum value of inductance as 60 microhenry. Please keep in mind that this is the minimum inductance required. To get a smooth current at the output, let's add a tolerance of 20%. As a result, our final value will be about 72 microhenry. Step 3. Capacitance, C. For buck converter, the value of capacitance is given by the formula shown below. Please keep in mind that delta V is the voltage ripple. Substituting the values, we get the final value of the required capacitance as 208 microfarad. Now that our required values are calculated, we can move to the making of our buck converter. I am using PSIM for my simulation, but you can do this in any simulation software, like MATLAB or PSPICE. Open PSIM by double-clicking on the software icon. Let's create a new project and save it as buck converter. Let's place the required components from the element toolbar as shown. Please note we require a ground and gating pulse block to provide the switching pulses. After our components are in place, let's connect them using the wire tool from the toolbar. Let's input our parameters and calculated values by double-clicking the components and typing them, as shown. Please note, I am assuming my components has ideal behavior. Double-click on the gating block, and input the frequency as 50 kHz. Keep in mind that we cannot input the duty ratio as percentage values. We need to input them in degrees. A duty ratio of 100% equals 360 degrees. Therefore, a duty ratio of 40% equals 144 degrees. If your value has decimals, which can happen, round off the number to the next integer. With our components connected and our values in place, let's add voltmeters at the input and output to read our input and output voltages. Click on Simulate in the menu bar, and select Simulation Control, and place it anywhere in your workspace. Let's input the run time of our simulation as 2 seconds. The sampling time will be adjusted automatically. Click on Run Simulation in the toolbar to run our simulation. In SimView, select the input voltage, click on Add and press OK. As you can see, we have an input of 50 volts. Click on Add one screen in the toolbar. Select the output voltage, click on Add and press OK to view the input and output voltage as separate graphs. As you can see, as per our calculation, we get an output voltage of 20 volts, for an input voltage of 50 volts.
Thanks for watching. Check out these cool videos from the Curious Pug. We are sure you would like. Leave a like and comment what you think in the comment section below. Don't forget to subscribe to the Curious Pug and ring the bell icon to get notified about the latest updates from the Curious Pug.